Okay, everyone, let's continue. So, we off. So your ideas can certainly come from just casual observation, kind of unsystematic, but it of course helps to read the literature. So, um, ideas can certainly come after the literature review or before. And of course, your Springboard articles, which are detailed elsewhere. Another thing to think about just when generating research ideas, and this is kind of important to consider for your papers, your writing assignments, is do you want to try to support or not support a theory? So you're going to look for evidence that's consistent with a theory that would, to some degree, I don't want to say rule out, but go against a theory or makes a strong inference. We'll come back to these three approaches later on. Kind of what I would recommend is easier, and in terms of generating a research idea, is to think about a real world problem. So I kind of picked the Springboard articles that were a bit more on the practical side. So you can kind of hopefully think of a more practical issue you might be interested in. That's kind of, I think, going to be easier than dealing with something more theoretical. So a few more things about developing a good research question. Again, this is kind of part of the research process to consider, but also to consider for when you're reading your Springboard articles and stuff and doing writing assignments is you want to ask something obviously pretty answerable, right? So remember, a definition of science is that can it be tested empirically, right? Can you find variables that are actually measurable? And by the way, I should clarify, you're not actually running these studies, but you still need to be able to write about them as if you would do them. So, you don't need to have, I don't know, computer program that's going to run your experiment, but it should be at least it should be hypothetically possible. Just while we're on the subject, also, um, how you measured your variables is known as an operational definition. Okay, so when you have research questions or terms, kind of the underlying construct or the underlying process that you're interested in is going to be known as a hypothetical construct. So if I'm interested in false memory or memory encoding, those are hypothetical constructs. And those tend to be more at the theoretical level. When you get into an actual experiment or whatever kind of study you use, um, how you actually measure those, how you transform those constructs into an operation, into something measurable is known as an operational definition. Okay. And also on the subject of collecting data, important things to consider is how you're going to measure things. So again, like a lot of topics today, we'll kind of come back to these throughout the course, but some important overarching themes are, is the measure valid and is the measure reliable? So valid means, is it actually measuring what you think it's measuring? So if I'm looking at, measuring depression and I use a scale that is more tapping anxiety or mood swings or something like that, well, then it's not very valid, obviously. It's not measuring a hypothetical construct that I'm actually interested in translating into a number. That's validity. Reliability, on the other hand, is the measure consistent? So, let's say, just again hypothetically, the same person with the same level of depression takes the test twice, the depression test. Well, they should hypothetically get the exact same measurement, right? If they don't, then the scale's not really reliable. Again, I know that wouldn't happen in practice because the person would vary from day to day, but hypothetically, if they were exactly the same, the most reliable scale or the most reliable measurement should not change as well. Another analogy would be, let's say you're weighing something and it weighs 200 pounds, but so if you weigh it again and the weight has not changed, you haven't chipped away at it or anything. Um, if you put it on the scale and every time it says the same number, whatever that number might be, then it's reliable because it's producing a consistent measurement. Okay, so a few more things to consider with your research ideas, and also again just with reading research in general, is, are you asking important questions? Not all questions have to be groundbreaking. In fact, a lot of them aren't, and that's totally fine, but it should be at least somewhat useful. So you should be able to kind of explain to someone, um, if you're going to put, again, I know we're not actually collecting data here, but if you were to invest the time in collecting data, spending grant money or whatever it might be, is it worth it? Is it just something you're curious about, or is it actually tell us something about a theory, or is it somehow practical, or at least could be practical? Okay. Just one last note is the hypothesis should generally come before you run your specific test. That's not to say that, hypotheses can't be generated after other data has already been collected. So you can look at what other people have done collecting data, generate a hypothesis, and then, collect more data of your own. But your specific hypothesis should be coming before testing, before running your study. So a big thing, in psychology, and this is even kind of a well, I wouldn't say controversial, but something people talk a lot about is whether people are kind of reasoning what's known as doing post hoc reasoning as opposed to a priori reasoning. So a priori reasoning is, or a priori hypotheses rather, is when you decide, you make a prediction before you run your study, not after the study. Post hoc reasoning or post hoc kind of analysis, hypotheses are generally not what we want to do, where you collect your data and then you say, well, here's what I predicted. That's not really good because we don't want to kind of rationalize something or explain it after we've already investigated it. That's not to say that if something goes against your hypothesis, it can't be interesting, but it's kind of cheating to change your hypothesis based on what you found. So it'd be kind of like, that's a good example here. Um, someone who claims they can read the future, but then they only say, "Oh, I knew that was going to happen after the fact," right? In order to actually test something kind of more objectively, they have to make a prediction before it happens. So a few things to also consider when you're reading other articles related to your Springboard is these should be very useful in helping generate research ideas, like I said. So both in terms of considering theories and developing empirical questions. Um, Another thing is that you want to avoid needless duplication of effort. So your study that you propose has to be new. It can't be what's called a replication. It can't be just, okay, this is what this person showed, I'm going to show it again using the same methodology. It has to be a new question and an extension of what they did. Now, a lot of times, extension kind of comes hand in hand with replication. So, um, if you're running a study and you're building on something, you're almost going to necessarily include a replication, and that's good, but it can't be only a replication. For example, let's say someone did some sort of false memory study, and they found that people remember words or faces or whatever it might be that they never actually studied. Well, maybe a follow-up question is, how does that work with older adults? So as we get older, do we show more false memories? In that situation, it's going to be a replication as well as an extension because you're probably going to use the same methodology as they did, but you're going to run it for both older adults and younger adults. So that's what we mean by replication. Oftentimes, not always, but excuse me, often going hand in hand with extension. Another really useful thing to consider when you're reading literatures is you can think about ways to design your study. So you can certainly, it's not plagiarism as long as you cite them, to use others' methodology, kind of inspire your test from their test. So for example, if you're thinking about, well, I have this good idea, but I'm not really sure how to implement it into an actual methodology, well, reading other papers that have investigated that topic will very likely spark something. And you can also consider, when reading those studies, learning from their mistakes. So they might have ran a study and found, well, this particular method doesn't work, you have to do it this way. That can be useful. Okay. So something else important to consider when you're reviewing the literature is, what's the actual authority, or is there an authority that you're looking at? So, an authoritative source like a journal article is great because it's peer reviewed, which we'll talk about next. Something like a book, or even someone who claims to be an expert, is probably more likely than not an authority on a certain issue, but not always, right? You don't need to know what you're talking about to write a book. It just has to be interesting to people. So sometimes you'll get books that are not really written by an authority. They're just written by someone who thinks they know what they're talking about. Also, on the subjects of books, make sure to consider who's writing it. Is it empirically backed? Stuff like that. Books can be useful kind of in the newer phase, in the earlier phases of getting a research idea, but we want to move on from that eventually, or rather sooner, to actual empirical articles, which we'll talk about in a second. So the thing about books is they might not be authoritative. They might be, again, written by someone who doesn't know what they're talking about, or isn't actually a researcher in the field. They could be very biased, for sure, and the answers may not be known. So just keep that in mind at all time, and also keep in mind that scientific explanations are going to be objective and kind of systematic. So if that's lacking somewhere, then it's probably not worth reading. Okay, well, let's talk a bit more about the quality of sources, reading articles, hypotheses, and theories. Okay, so again, just to recap, scientific explanations are rational, but they're also consistent with facts, right? So kind of the logical part is only a small piece of the bigger puzzle. It's not enough to just say, well, it makes sense that people would reason this way or think this way, remember this thing, but not this thing, right? But that's not enough, because like we talked about earlier, psychology especially can be very counterintuitive, right? So it has to go from, maybe start with rational, logical explanations. It has to also move on to observations that can actually support or refute the explanation, or the theory, or the practice, whatever it might be. Okay, another important quality of science is that explanations, theories, whatever it might be, really any aspect of science, are based on being tentative and being cautious. So, when we develop a theory, whether it's about social behavior, some aspect of cognition, so on and so on, it's very important that we be tentative. We never really accept something as absolutely true. We always deal with things being either supported, varying degrees of support. So it's not supported, it's moderately well supported, it's pretty quite well supported, but it's never proven true or never proven false. So if you say prove, your professor will make this face. Now, why is that the case, you may be wondering? Well, there's there's actually a few different reasons. But one is just that everything we do is based on probability, right? So when you run a statistical test, which we'll talk about more later, it's based on probability. It's not based on proving something or disproving something. So you might find that, say, there's a whatever percent chance, a 4% chance that your manipulation had an effect, or that there is a significant correlation between two variables. Well, that doesn't prove anything. It just suggests that the odds are your manipulation had an effect. It doesn't matter how, strong the evidence is. You could have a p-value of less than 0.001, so less than 1% chance that your results were a fluke and that your manipulation very likely did have an effect. Again, it's still based on probability. So that's one reason why we don't say prove. We also don't say prove because science is constantly evolving and changing. So just to give you one example, you may have heard before that eyewitnesses are not reliable, and more specifically that their confidence is meaningless, right? So an eyewitness that's very confident is no more likely to be accurate than an eyewitness who is not confident at all. Their confidence does not predict their accuracy. I mean, it's not exactly my field, but people have flip-flopped on that issue quite a bit over the last while. So starting in the 70s, people were pretty convinced that you can't trust eyewitnesses, even if they're confident. Their confidence doesn't mean anything. Actually, not too long ago, I think it was about 5 or 6 years ago, it was proposed that confident eyewitnesses rather, can be trusted if certain criteria are met. I won't go into that too much, but you don't need to remember this, but just a big factor is whether you get their initial confidence or later confidence. So is it the first time they see the suspect or the second or third time? Because that is a big factor. Anyways, so that was kind of well supported that under the right circumstances, if they're confident, we can trust eyewitnesses. And now there's been quite a bit of pushback, and people are arguing that no, you still can't trust them, even under those circumstances. So the bottom line is kind of the takeaway of that whole story is just that science is constantly changing and evolving. So, another 5 years, we might be saying, yeah, eyewitnesses are totally trustworthy if they're confident, or we might be saying, no, you can't trust eyewitnesses, even if they're not, right? Things are constantly evolving and changing. So that's why we don't. New theories come along, confounds are discovered, stuff fails to replicate, so on and so forth. Bottom line is we don't say prove, we say supported. Just kind of building off that idea, the best theories or explanations tend to have the fewest assumptions and caveats. Because caveats and kind of assumptions do tend to, change the picture quite a bit. So just keep that in mind. But that's not super important. Okay. So more on this literature review. An important thing is whether you're using a primary or a secondary source. So a primary source is going to be anything that is like an original research study. So if it includes a full report of a research study, including methodological detail, like who the participants were, what the independent variable was, what their exact results were, you see all that stuff, and you see a methods section, then it's going to be a primary source. On the other hand, if it doesn't have those things and it's just a summary of other work or other of primary sources, then it's what we call a secondary source. So again, primary sources are kind of first-hand research reports. Secondary sources could be stuff like books, literature reviews, something called meta-analyses, and are summaries of other work that is actually primary. Okay. So also on that note, primary and secondary sources. So scholarly publications, like actual peer-reviewed journal articles, they can be primary or secondary. So when you're reading a paper, if it's, if it's in an actual journal, like an APA journal, it could be either. It could be primary or secondary. So just the fact that it's in a journal doesn't make it primary. Again, it has to have methodological details and be an actual report of an original finding. On the other hand, popular stuff that's not scholarly books some of the time, online articles or news articles or something like that, those are going to be always secondary. Okay. And by the way, primary sources are required for your paper. So a big distinction when looking at scholarly versus popular publications. Again, popular publications will be stuff like magazine articles, books, news articles, TV shows, stuff like that. Scholarly articles are going to be in an actual journal, so something like the Journal of whatever, personality psychology, experimental psychology. So there's like a whole bunch of them. They obviously differ in their intended audience. So scholarly journals are intended for people like us. Popular publications are intended for just the average person. Let me see. Okay, so, and that's kind of another way to look at it too, is consider who's actually publishing the information. So if it's a news site or a news organization, PBS, then it's just meant for the average person. If it's something like the CDC, it might be a bit more. It's probably more official. So again, published articles, scholarly articles rather, are published by professional organizations like the American Psychological Association, and they investigate current research and theory. Another big difference between scholarly articles and non-scholarly articles is that scholarly ones go through something known as peer review. And this is a very important process. So when you submit an article to a scholarly journal, you send it in to whichever journal you're interested in publishing it in, and then what's called the action editor, so the person who is, or no, it actually goes to the head editor and then the action editor. The action editor is going to be someone who knows a fair amount about that field, so they might divide a journal up to, here's this perception researcher, here's this memory researcher, here's this attention researcher, and so on and so on. So if you submit a memory paper, it will go to the memory person, obviously. And then what they do is they contact people who are experts on that topic. So if I'm submitting an article and it's based on, I don't know, a particular kind of false memory, well, they're going to contact people who are experts in false memory who have published on false memory, and they're going to ask them to review it. When they review it, they kind of evaluate the strengths and weaknesses of the paper, and they give a recommendation as to whether it should be published or whether it should be rejected, or what's called a revise and resubmit. So, well, actually, all papers, first-time papers, papers that where you submit them the first time, generally get either a revise and resubmit or a rejection. Nothing gets published the first time. So, anyways, the experts in the fields, they look over the paper and they decide, is this a good paper? Is it addressing an important question? Is it worthwhile? Is the methodology sound? Are there confounds? Are there problems with it? Just kind of evaluate the overall, quality of the paper. If the paper is good quality and interesting and worthwhile to the field, and the issues are fixable, then they send it back and you get it. You get the revise and resubmit. You have to make some changes and then resubmit it. On the other hand, if it's not of high quality, there's major issues with it that can't really be easily fixed, then they reject it. So this part is really important. You probably don't have to remember all that, but this is the peer review process. So people who are experts in the field, evaluating the manuscript or the paper and deciding whether it is worthy of publication or not. And this is a really important process that separates scholarly from non-scholarly articles. So as you could probably imagine, because something is going through rigorous review and scrutiny from other experts in the field, the stuff that gets published is going to be high quality. It's going to be scientific, and it's going to be proper designs and all that good stuff. So like I said, yeah, this is intended to ensure the quality of the research that is published. It's not like you can submit something that's not really methodologically sound or not a worthwhile question, because it'll obviously get rejected. And although this is, a decent system, it's of course not without its problems. So just because something is published that's peer reviewed doesn't mean it's high quality, doesn't mean it couldn't have problems. All the time stuff slips by that is not, entirely solid. There's a number of things that contribute to this issue. One being agreement with the findings. So obviously, if I have a certain theory about, say how memory works, whatever, and I'm reviewing a paper that agrees with that theory, I might be more open to wanting to get it published. Whereas, even though it's not mine, but it does support my theory. On the other hand, if someone submits something that really goes against or is even critical of work I've done, well, obviously I'd be pretty resistant and probably look harder for issues with it. And we'd like to pretend that the review process is totally objective, not subjective, but it's not. It's there's definitely subjectivity. Like, I've come across articles like, how in the world did this get published? It's a total piece of crap. And I've even come across articles that were published in kind of low tiers, so not very high quality journals. I'm like, this should absolutely be in a higher tier journal. It's really good work. Obviously, there's some subjectivity to it as well. Just another thing that can contribute to this issue is the reputation of the author. So, if someone like a really big name submits an article, it probably doesn't get the same amount of attention as some, or same amount of scrutiny as if, say, a graduate student were to submit it. And, the people are just probably more trusting naturally of, and I mean, I don't think it's fair, but I don't entirely blame them. People are going to be more scrutinous of something from a famous person rather than someone who's just kind of starting out in the field. Actually, I'll tell you a quick story on that note. When I was an undergrad, we're just finishing up undergrad, my then supervisor asked me to review a paper with him. and it was actually by someone really famous known as Elizabeth Loftus, and she basically discovered false memory and launched so much research. So it was a paper by her, and reading, I'm like, well, okay, I'm just a lowly undergraduate here. Am I really gonna spot any issues that, you know, someone this famous in a paper written by someone this famous can't happen, right? But actually my supervisor sent me his review and I'm like, oh yeah, here's some problems. How did I miss that? Kind of like bottom line is the reputation of the author can be problematic. One way around this though is to have blind reviews, so to have not include the name of the author when they submit it, which probably helps, but it's sometimes you can tell anyways because they'll cite a bunch of their previous work and you kind of know that, oh, this is the person that researches that area, and it's not perfect. But again, takeaway is that on average, articles in refereed journals are of higher quality, but that doesn't mean you shouldn't think critically. Okay, so remember to check when you're thinking about the quality of the source. Is it a scholarly journal? Is it peer reviewed? If you look at the paper, there should be information like that. You should be able to tell. And is it a reputable publisher? So using Google is not very good, or Google Scholar is good, but not perfect. But PsycInfo is really good because I think that'll take you straight to journal articles and not just like opinion pieces or news articles or whatever else that's not scholarly. So big issue, kind of like we touched on with books, is that unlike journal articles, they don't go through peer review, or at least, well, sometimes they do, but usually they don't. A lot of times you just need to write something sellable. It doesn't need to be, often doesn't get reviewed by actual experts in the field in the same way that a journal article would. So books are usually, I want to say always, but there might be exceptions. So I'll say usually secondary sources, but almost always secondary sources. They might not also be up to date. So it's not like, people publish reviews on the same topic like every few years. They tend to, get maybe one book like every 20 years. So it might be kind of out of date. That's another issue to consider. But yeah, like I said, the main issue is that books can be written by anyone and they don't go through peer review like journal articles do. So if there's, bogus claims in a book or non-scientific stuff, that doesn't mean it's going to get rejected in the same way that a journal article. That's your extra credit assignment. I'll let you do that. Just one more secondary source that you consider using is something known as a meta-analysis. It's a meta-analysis. This is something you can do where you combine the results, basically a whole bunch of studies. So you look through the literature, you'll even contact authors who have stuff that was never published on a topic, and you include it all, and you run what's called a meta-analysis, and you kind of determine, is there something there, what moderates it, and what is the actual effect size. So just to give you an example, something we've kind of touched on before is known as the testing effect. This is the finding that taking some sort of practice exam or practice test is actually a really good way to study for a final exam. So there was a meta-analysis published on this issue because there's a whole bunch of experiments on it. So they took all these different studies and looked at, well, what is basically the average actual effect size? How much on average does testing actually improve memory compared to, say, a different strategy of rereading your notes? That's what we're doing with meta-analyses. So just some other things when you're reading articles to consider is when you're looking at the introduction, look for the hypotheses and the research question or questions. and kind of consider whether other studies on the topic have they supported their hypotheses or hypothesis. Again, just because it's peer reviewed doesn't mean it's solid. So think critically, even if it's in a peer reviewed journal, are the methods adequate to test their hypothesis? And are the measures valid and reliable? And if they are, well, then that might be a good reason to do something similar. Not the same thing, but kind of apply their methodology to what your research question is. Okay, let's see. By the way, just while we're on the subject, so each, and we'll cover this in elsewhere, but each paper is going to have these sections. It's going to have an introduction, method section, results, and discussion. So the intro is where they're going to introduce their research question. They're going to kind of go over what do we currently know about this issue and what do we not know that we're currently testing. So that's where you should be able to spot the hypotheses there. The method is going to be where they're going to go over exactly what they, how they went about answering their research question. What did they do? And the results are going to be where they report all their stats, the tests, and stuff like that. Okay. Let's see. Let's see how much. Okay, so a couple last things. When you're reading, another thing to think critically about and cautiously about when you're reading the results section is, are the results significant? Obviously, but for example, is the p-value less than 0.5? But that doesn't necessarily make something practically significant. So if your goal is to apply this in the real world, it might not be enough for it to just be statistically significant, might need to be practically significant. So, for example, are the effects actually large enough to matter? I'll give you an example in a second. So just as an example, let's say a researcher did a study and they found that this particular study technique that takes 20 hours a week improves grades by an average of 2%. It might be statistically significant. The p-value might be less than 0.05. That doesn't make it practically significant. Why is that? Well, because studying an extra 20 hours a week for an increase of 2% is not worth it. Right? Again, it's statistically significant. That doesn't make it practically significant because it's not worth it, right? If we found that the study method only took 5 hours and increased grades by 10%, well, then maybe it's practically significant. Some last things to consider when you're reading a discussion. So this is going to be where they talk about the actual implications of the study. What does this tell us? And what are some future directions? Are the conclusions consistent with the findings? And they should also acknowledge the limitations to the study. Break there.